Hi there, welcome to Architect Interview Question Series from Knowledge Powerhouse. We go on to our next question in the series. The question is, what are acid properties? So acid properties, these are like a question which is coming up around database management system, relational database management system kind of a area. So here we need to know what are the acid properties of transactions. So acid properties constitute it's an acronym for four words, which is atomicity, consistency, isolation, and durability. So which is like first letter of it. So that stands for acid. And these are mainly around the database transactions that we do in relational database. And that is what expected of a transaction in an ideal case. So let's go on to understand each of these items one by one. So atomicity refers to like some example, understand from the example. As let's say we are transferring some money from A to B in a transaction. So we are moving like $100 from A to B. So in this case, we have to reduce the balance of A and increase the balance of B. So both of these things should happen in the same atomic unit. Then only we consider this whole transaction is atomic. That's what atomicity stands for. Otherwise, if you just reduce from A but do not give like increase the balance of B and your transaction fails, in that case it will be in a hanging state where the system will see, oh, there is less money in the system, but in reality it should not be. So if any of this operation fails within that atomic transaction, the whole transaction should also fail. That is what atomicity is. Then consistency relates to whenever we write a transaction to the database, then it should honor all the rules like triggers, constraints, etc. of the database system. Then only it is considered like a consistent transaction. For example, let's say you have a constraint that account balance cannot be like less than zero, right? So if we are trying to reduce money from somebody, deduct some money from somebody's account, then if we come across this kind of a situation that account balance is going less than zero, the transaction should fail, that it is not allowed. Like for example, if age should not be a negative number. So if somebody is trying to do that, that constraint will come up and we will not be able to enter the incorrect data. So similarly, like there are many triggers are there, so those triggers also before after transaction kind of a thing, they also has to be satisfied, then only transaction is committed. So that's what consistency refers to, that your database always remains in a consistent state. Consistent state is the state where all the rules, all the constraints, all the triggers that you have set up on the database, they hold true. The third is properties isolation. So in isolation, what we refer is that there are many times on a database concurrent transactions will come, two transactions come at the same time. So let's say two requests come to transfer money from A to B. So if we have isolation property, then the net effect of these requests will be same as the effect of executing these transactions one after another, which means like we do not intermix two transactions and try to summarize them or something. We actually do transactions in atomic way one after another, and they take place in isolation. That let's say we transfer money, so first one transaction takes place, then the next takes place, and some of that is the like net effect of it. So that's how this isolation works. Okay, the last one is durability. Durability also is a very important concept. Here it means if a transaction has been committed to the system, then it will maintain the same state even if the machine crashes. That was an important part for like ACID transaction, that if we say the transaction is committed, it means machine crashes and we restart the system, we find that transaction was actually taken place. So transaction is recorded in a place so that even after a crash, we can recover it from there. That's what a transaction is durable. Otherwise, like if we start losing transactions due to machine crash, In that case, we will be like losing a lot of data, a lot of information, and the trust will be lost. That's why we go for durability of a transaction. Now, coming up to the context of RDBMS, why ACID properties are important? Because when we were designing or evolving the database management systems, especially the RDBMS, we try to maintain all these properties in one form or another. Then only these popular databases like Oracle, SQL Server, they became like much in the use, because the transactions from these databases followed ACID properties. Whereas when we are using distributed data systems like NoSQL databases, here it is very difficult to ensure all the properties of ACID properties of a transaction, and due to this are not able to use many distributed databases for relational database design. So ACID properties are definitely a must for RDBMS, whereas ACID properties are not thoroughly followed by all the distributed data stores like Hadoop and all, due to which they are not very much useful for RDBMS like OLTP transactions. This is an important point to remember. All right, thank you, listeners. And if you have any questions or comments, do post into the comments. We'll be happy to answer for you, and subscribe to the channel. Thank you.